So, it seems that Frédéric is a popular name because our next speaker is also Frédéric. And we are moving on to something solid. A solid project, a solid foundation for data spaces. And I think for that one, who's going to present? Guillaume, Frédéric, the two of you? Guillaume. Okay, so Guillaume's going to present. He's the founder of Virtual Assembly with me here. Thanks a lot. Stage is yours. That one.
Hi everyone, I'm Guillaume Rouyer. I'm a PhD student at the French Agency for Ecological Transition and at the Troyes University of Technology. And I'm also part of the Virtual Assembly and ecosystem of people and organizations which develop software projects based on the solid protocol that we are going to present you with Frédéric Lay, AFNet expert who represents the association within the Gaia-X architecture working group. We would like to present the solid project which we believe could be an interesting technical foundation to complement initiatives such as Gaia-X and International Data Space in the development of data spaces. Sylvain Lebon, co-founder of Starting Blocks, a French startup, has been unable to join us for this talk. He sent his apologies. So let's start with a brief history of Solid. The Solid project is linked to the history of the web, its challenges and developments, and to one of its key players, Tim Berners-Lee, who invented the web in 1989 and subsequently tried to fix it through two main projects to overcome its limitations and correct its main weaknesses. The semantic web in 2001 to enable users to find, share, and combine information more easily, to make data on the web machine readable, and the Solid project in 2015 to give users back sovereignty over their data in a context marked by the abuses of GAFAMs, of centralization, and of the exploitation of personal data for abusive purposes. Solid was born at MIT in 2015. It then evolved as a community group at W3C. It's now being standardized. The process should be completed by 2026. So what is Solid? What is Solid? Solid is a specification that lets individuals and groups store their data securely in decentralized data stores called pods. Pods are like secure web server for data. When data is stored in a pod, its owners control which people and applications can access it. Any kind of data can be stored in a solid pod, from structured data to regular files, like binary files, that you might store in a Google Drive or Dropbox folder. Individuals and groups can grant or revoke access to any slice of the data as needed. Let's see a first use case. Atumi is a public company created by the Flemish government and that develops some softwares and applications based on the Solid specification. Why they use Solid? Governments create lots of authentic personal data. Reuse of this data is restricted because of the GDPR and the unbalanced relationship between citizens and government. Can governmental processes be simplified by putting citizens in control of the data? How can citizens share the data with government administration within the context of GDPR? How can citizens reuse their personal data stored in government systems in a different context? Atumi has 2 million euros annual budget dedicated to solid projects and a team of 15 people. The first use case concerns the sharing of diplomas. Employers face many cases of diploma fraud. My diploma aims to secure the sharing of certified documents, like diplomas, between stakeholders. Through a government app called My Citizen Profile, a pod, or data vote, can be created by every citizen in Flanders. A citizen can grant a right access to his university, for example, the Ghent University, so that it can send certified diplomas on the pod. If a company like Randstad, which is partner of the experiment, needs a candidate's diploma, it requests a reading access to the certified diploma located on the pod of the candidate. It's the first use case they address, but they have other use cases. The following ones will be related to personal data in the fields of energy, of health, and banking. The objectives of Atumi is to extend the scope of the use cases and to provide solutions in other countries around services that need to manage personal data in a decentralized way. Let's take another use case. The Open Food Network is an international community developing an open source software for decentralized food marketplace. In order to sell their products as effectively as possible, producers have an interest in using several distribution platforms. But it's complicated. When a product is sold via one platform, they have to manually update their stock on the other platforms. This problem is solved when the data is separated from the platforms, as in the case of Solid. On this schema, a producer, the yellow one on the top of the schema, sells his products through both Kajet.net, the pink marketplace, and CopSecret, an instance of the Open Food Network software, the purple one in the schema, on the schema. He gives them read-write access on his pod. If a client buys some products using Kajet, Kajet will update the producer's product stock directly on his pod. If another client wants then to buy a product using CopSecret, CopSecret will fetch the data directly from the producer's pod with a guarantee of an up-to-date stock. So how it works? All data in a solid pod is stored. It is stored and accessed using standard, open, and interoperable data formats and protocols. Solid uses a common way of describing things and the relationships that different applications can understand. If we take a look at the Solid standard stack, we can see that Solid is built on existing standards. At the bottom, the web layer enables the exchange of documents and communication between agents using HTTP, TLS, and common data formats. Then, on top of the web layer, the link data layer provides standards for structuring and linking data through RDF, Resource Description Framework, human and machine understandable data with semantics, and knowledge representation via ontologies and shared vocabularies. He provides also some principles for producing and sharing fair data which are easily findable, accessible, interoperable, and reusable. Solid's innovation lies in the third layer, which aims to provide a feature that is missing but crucial for the web: access. This implies standardizing distributed identification and authentication management mechanisms, which are Web ID and potentially decentralized identifiers, and a special flavor of OpenID Connect that is called Solid OIDC. This implies also standardizing access control protocols, the Web Access Control Protocol, and finally, read-write link data API, which is called Link Data Platform. Frédéric?
Thank you, Guillaume. How do you go to the next slide? Is it the green one? Thank you. So Guillaume has presented a few use cases, and now I'm going to do a deep dive into the architecture itself. But before I do that, why did we think that Solid was an interesting topic for the technical community? First of all, Solid is going to be used, or there is some thinking around using it in a few data spaces. I'm thinking of the media data space in particular, but not only. And as you'll see, Solid does not cover all the needs of a data space platform. So it will be important also to understand how to connect Solid open source component with other components that are created in the open source community, and especially the ones that are important for data spaces. And what we've seen this morning in the Gaia-X presentation, but also in the beginning of your presentation, Guillaume, is that all those components follow the same web-based standards, and many of them being standardized by W3C. Therefore, there should not be too many technical obstacles to do that type of integration. That's why we really invite the technical community of Gaia-X to also be involved in those integration initiatives. And I will talk about later on what are the key integration points that we need to focus on. But before I do that, let's talk about Solid itself. So a Solid pod, and as Guillaume said, the pod, you can have many pods, and they can be used by more than one application. So you have a one-to-one relationship between pod and applications. And you've got a layer of decoupling between the application and the pod. How is that achieved? Basically, the pod exposes a REST API, and that REST API uses the link data platform, which makes interoperability quite easy. The link data platform enables you to basically attach RDF description to your data structure, and therefore, for instance, you can ask a pod, tell me which data structure you are working with. On the left side, you've got access control list support. So there is a very simple access control approach with Solid, which is far less sophisticated than the type of access control mechanism we find, for instance, in enterprises, where you can have more than one roles, and you can attach to those roles access control policy. And I'm not even talking about representing contracts using some rule-based language to actually verify that data set can be accessed or not. So it's very simple. So I ask one of the Solid guys, why is it so simple? Because it does not cover many needs, and the answer was simple. Simple, not the European project. The answer was, well, it focuses really on individuals, and therefore many needs from the point of view of cooperation and enterprise are not part of the scope of Solid. In terms of how information is stored, it's stored in containers. And as Guillaume said, it can contain files, but it can also contain semi-structured document specified using RDF, the RTF standard. And you can modify the data within a pod, that's the patch update, but you can also issue notification, and therefore you can also use a more events-driven style to communicate between the pod, the application, or between pods. So that being said, how is it positioned vis-à-vis the DSSC technology building block? I will not introduce you that diagram, you all know it. Let's say that it's mostly focused on data models and data exchange, but it does not cover all the functionality you could expect from data modeling or data exchange perspective. It also covers data access, identity, but here again, it does not cover all the needs, and also publication history, but also it covers only a subset of requirements. So if we talk about integrating solid components within a data space, we probably have to work on the identity side, because today Solid does not take into account, for instance, trust anchors, certificates, and actually there are a few projects that are working on that one. Why would it be important? Let's say, for instance, that you are a supermarket, and if you would have the integration with a trust framework, as a supermarket, you would not have to re-verify the information of your clients every time. So we see that it's something that would be useful in many use cases. The second aspect that needs to be taken into account in that integration is the connector side or the data exchange services side, for instance, that was presented by Frédéric a few minutes ago. And if you look at connectors, though it has not always been the case with connectors, now you distinguish clearly in those connectors the control plane from the data plane. And the Solid is more, I would say, positioned on the data plane. So we could very well see an integration where a connector or a data exchange services would basically verify that a user of a data product can use the product and under which rules for instance, verifying some ODRE rules. That would not be the scope of the solid component, but then it would give control to the solid component who would perform the data transfer itself using the solid protocol. So all those integration ideas are in progress. I don't think that it's completely settled, and probably there is more than one way of doing it. But we don't see any reason why those integrations could not be achieved. At least there is no technical reason, we believe. And the two last slides actually were created by Sylvain, who could not make it today. But basically, I think that in my comment of the previous slide, I've covered most of the topics that were in those two slides, especially there is one thing that I've not covered, but one interesting thing in those decentralized pods is that, for instance, you could have basically a decentralized way of looking at inventory. For instance, inventory of medias, or in a construction data space project that I'm working on, we are thinking about having a decentralized way for construction product producer to describe their catalogs, and those catalogs could be handled in a sovereign manner by all those construction product producer, and they would have control on their data, on their catalog. It would not be in a centralized data space or data repository, so to speak, and it would be under their control. One way to then achieve the search capability, for instance, you would have designer, architects of buildings would like to find products that meet some requirements, then they could, the search capability could be implemented by a solid application that would basically query all those spots for all the construction product producer, and then retrieve only the subset of products that would meet, for instance, the performance requirements of the architect or the construction company. And in order to do that, you need to standardize a few things, the index format, the data that you will use for discovery and querying, and create a distributed search engine. So these are the type of development that we could do based on that technology. We need also to talk about the limits. We see that the web access control list is limited to simple access control, so there should be probably more work to do to, for instance, incorporate roles so that you could use that not only for personal data, but in the context of an enterprise with employees who would have different roles. We see that web IDs are really self-sovereign identity, but we need convergence with distributed identifier, and in particular the standard that's being developed under the W3. Can you hear me still? Oh, thank you. And last but not the least, because we are talking about personal information, eIDAS is important, and we probably would need to integrate the way identity is handled with Solid with EIDAS, but here again, that's not that difficult because I've seen, for instance, one of the firewall component that firewall use for authentication, key clock, a development to integrate identity handle with key clock with EIDAS, and I think that there are similar work done in the context of Gaia-X to integrate EIDAS. So that's also something that could be done. So I see that we still have a few minutes, so either we take that time to give more time to the other talk, or if you have a question, we have a few minutes for questions. In that case, thank you very much, and we will give that time so we can maybe have a lunch a little earlier.
Thanks a lot.